In this segment, I want to start introducing some of the terminology we use to describe motion. And we're going to start with two words that you've probably used in your real life: speed and acceleration. So these are words that I'm sure you've run into in outside of science class, but it's possible that you've used them in a way that was not quite as precise as the way that we use them in science class. And to start off with, let's just think about your prior knowledge. Let's try and figure out where you're at. And so here's a question for you. Look at the PowerPoint, and I have two speedometers here. Which car is at a higher speed? Is it car A? Is it car B? Or is there just not enough information? When I ask you these questions, go ahead and pause the video, make a decision, and then once you've decided on your answer, hit go, and we'll talk about it. Okay, so hopefully you decided that the higher speed is car A. And it is a speedometer, right? These are pictures of speedometers. And speedometers are appropriately named. They are speedometers. They determine your speed. They measure your speed. And so I look at this and I say, hey, this car is going 100 miles per hour, and this car is going, 62 miles per hour. Okay, clearly, car A is going faster. No big deal. How about this? Which car has the greater acceleration? Is it car A, car B, or is there not enough information? Go ahead and pause the video. I'll see you on the other side. Hopefully, you said, C, there is not enough information. What piece is it that we're missing that would allow us to answer this question? Well, the piece that we're missing is how fast the speed is changing. In a way, we're looking for whether or not these needles are moving, right? If the needles are moving, then the car is accelerating. But if this car has been going 100 miles an hour for the last, hour, then you know what? It's not accelerating. So we don't know how their speed is changing, so we don't have enough information to answer questions about acceleration. Okay, so what exactly do these terms mean? In order to understand acceleration, which is the trickier of the two, we need to understand a new term, and that is velocity. Velocity is very closely related to speed. Speed is how fast, and that's probably, you're bringing a definition of speed into this class, I'm sure, and I'm not going to mess with it very much. Speed is just how fast you're going. That's what your speedometer tells you. Now, velocity is how fast and in what direction. Okay, so it just includes the direction. There are some things in nature where direction is just really important, right? I've got this rock here. This rock, I don't even know. This rock it's pretty heavy. I don't know. It's probably a 20-pound rock. This is probably a 20-pound rock. 20 pounds west. Does that make sense? No, that doesn't make sense. Doesn't make sense. A direction has no meaning if I'm talking about just how much that rock weighs. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 pieces of chalk in this box. Does that need a direction? No. 10 pieces north? What? That doesn't even make any sense, right? So some things in nature need a direction, some things don't. Things that need a direction are, velocity. Why? Well, if I just tell you I'm going 60 miles an hour, does that tell you where I'll be in an hour? It really doesn't, right? There's a piece of information that's missing. If I know I'm going 60 miles an hour north, now I know where I'll be in an hour, right? So there's just something about velocity that requires a direction, right? For a complete description, if I want to know what I'm going to be doing in the future, I just have to have direction. It's just the way it is, right? And so in physics, we distinguish this with two different words. We say speed is just how fast, and we say velocity is how fast and in what direction. And so if we look at these cars here, these are some race cars going around a corner. Maybe they all have the same speed. Do they all have the same velocity? And the answer is no, they do not have the same velocity. The reason they don't have the same velocity is because they're not all traveling in the same direction, right? This black car in the end here is kind of going there to the right. This white car here is kind of heading more to the left, and one of these cars here in the middle, maybe this guy is coming directly towards us. So even if they were all traveling at the same speed, then they would have different velocities. Okay, speed and velocity, those are two of the terms we're going to hit in this segment. The third is acceleration. Well, what is acceleration? I've told you that you need to understand what velocity is in order to understand what acceleration is. And that is because acceleration is a change in velocity. So we can change the speed of an object by either speeding up or slowing down. Those are accelerations. We call those the rate of change of speed. Now, I suspect that for most of you, we've already branched out from the definition of acceleration that you brought into this class. I suspect that the definition of acceleration that you brought into this class is speeding up. You're not wrong, it's just not complete. Speeding up is one way to change your velocity, but so is slowing down. So speeding up and slowing down are both examples of acceleration. Since velocity is speed and direction, another way that we can change velocity is by changing direction. And so acceleration can be speeding up, slowing down, or turning a corner. Again, I think you probably only brought one of those definitions into our class. When we start talking about forces here in a week or two, then we'll see that there's a very, very good reason why all of these things are categorized together, why speeding up, slowing down, and turning are all called accelerations. For right now, you just have to kind of take my word for it. If a car accelerates at 20 miles per hour per second, that means that every second the car speeds up by 20 miles per hour. So notice the units there. They're a little bit weird. This is 20 miles per hour per second. It means every second the speed is changing by 20 miles per hour. So here's a question for you. If it starts going 20 miles per hour, how fast will it be going 1 second later? Pause the video, see if you can figure it out. I'll see you on the other side. Okay, hopefully you decided that it would be going 40 miles per hour. How do we know that? Well, because our acceleration is 20 miles per hour per second. So that means every second it's increasing by 20 miles an hour. So if I started at 20, then 1 second later, I am going 40. Here's another one for you. How fast is it going 2 seconds later? Hopefully, you decided that it is now going 60 miles per hour. We could make a little table if we wanted to. So here I've made a little table. We've got time and speed. At 0 seconds, it was going 20 miles per hour. At 1 second, it was going 40. And at 2 seconds, it was going 60. Notice that the difference here is always 20 miles per hour. Every second, I add 20 miles per hour. The acceleration is 20 miles per hour per second. What goes here? Hopefully you said 80. Of course, that's assuming we maintain a constant acceleration. If you've ever driven a real car, then you know that you could not maintain this indefinitely. So let's talk units really quick. We've said that our standard unit in science for length is meters, and our standard unit for time is seconds. So that means that our standard unit for acceleration is meters per second squared. It's what's called a compound unit. Compound units are units that are formed of combinations of the fundamental units, seconds, meters, and kilograms, that we learned about previously. So the units for acceleration in science are meters per second squared. We can interpret this as meaning meters per second per second. In other words, by how many meters per second does your velocity change every second? So, what does an acceleration of 1 meter per second squared mean? Does it mean you're traveling 1 meter every second? Does it mean that you have a speed of 1 meter per second? Or does it mean that you're speeding up at 1 meter per second every second? Why don't you pause the video? I'll see you on the other side. Hopefully you decided that we are speeding up 1 meter per second every single second. And frankly, the shapes that are offered in PowerPoint are just too confining for me. I feel like I can't really express myself. Okay, so in this segment, we've learned about speed, velocity, and acceleration. And we've learned that speed is just how fast. And if we're talking about speed, we don't care about the direction. But we've learned that velocity is speed and direction. And so if we're talking about velocity, we do care about direction. And as we'll see, acceleration also requires a direction for a complete description. So let's look at this simulation that I have here. This is called the moving man simulation, and we're going to use this for a couple of activities here in the incoming class periods. So let's look at this simulation and see what we can kind of learn about how to identify the direction of velocity and acceleration. So this simulation here is called the moving man simulation, and it's called that because there's a man and we can make him move. Okay, so let's just start with something simple. We're going to start at 0 meters, and let's give him a velocity of, let's give him a velocity of 2 meters per second. So I've given him a velocity of 2 meters per second. I'm going to hit go, and an acceleration of 0. Why don't you think to yourself, what's this motion going to look like? Is he going to move to the right, to the left? Speeding up, slowing down, constant speed? Let's see. Indeed, he does move. Okay. And specifically, where does he move? Well, he moves to the right at a constant speed. Well, what could we have looked at to know that? So we said his velocity was 2 meters per second. So our standard convention, and we will never deviate from this in this class, is that to the right is positive and to the left is negative. So if I go here and I put a velocity of, negative 3, let's say, what do you think it's going to happen? What do you think is going to happen when I hit go? Is he going to move to the left, to the right, speeding up, slowing down, constant speed? What do you think? Let's see. He moved to the left. How can we tell? Negative velocity. So negative is to the left. Positive's to the right. I don't have a simulation to show this, but I don't think you'll find it hard to believe that we also call positive up and negative down. So if I'm talking about horizontal motion, positive is to the right, negative is to the left. If I'm talking about vertical motion, positive is up and negative is down. Now, he moved at a constant speed, didn't he, in this simulation? How can we tell? How could we have predicted that? Well, if his acceleration is 0, that means that his velocity is not changing. And if his velocity is not changing, then his speed must be constant. Remember, velocity is speed and direction. If the acceleration is 0, that means his speed is not changing and his direction is also not changing. Okay, what happens if I do add some acceleration? Let's try something different. Let's reset this. Okay, so now I've got a velocity of 1 meter per second and an acceleration of 4 meters per second squared. Predict for yourself. What do you think this object's going to do? This man is going to do? Okay, well, let's see. I would describe what we just saw as moving to the right with increasing speed. Let's play it again and see if you agree. Yeah, I would say he moved to the right with increasing speed. Okay, that's reasonable, right? In fact, we started out at what? We started out at 1 meter per second velocity, and notice what we finished at. We finished at 8 meters per second. So, clearly, speeding up. Let's try something different. Let's try a negative acceleration, see what happens. We're going to go, this is going to be 5, and we'll do a negative acceleration here. Oh, I don't know, negative 2. Okay, here we go. That's interesting. What happened there? What happened there? Well, let's watch it again. Let's watch it again. So, initially, he was moving to the right and slowing down. But then he turned around and he started heading to the left and speeding up, didn't he? So I'm going to play it again. And this time, notice what happens to the acceleration. Remember, initially he was slowing down Then he turned around and he started speeding up. So notice what happens to the sign of the velocity and what happens to the acceleration. I'm going to play it again. Acceleration's still negative, isn't it? So notice that when he's heading to the left there, his velocity is negative. Okay, that jives with what we just learned, right? Negative velocities mean moving to the left. Did his acceleration change sign, though? His velocity changed sign, right? When he was moving to the right, it was positive. Then he turned around, he was moving to the left. The sign of the velocity became negative. What happened to the acceleration? Did it change? It didn't, did it? All right, we're gonna do another one here. Let's start with an initial velocity of 0 and an acceleration here of -2. Predict what the man's going to do. Pause the video. Okay, hopefully you've made a prediction here. Let's just see. Didn't he go to the left and speed up? So a lot of people in my class, when they first learn about acceleration, and then we learn that acceleration, the direction of acceleration is important. A lot of people think that a negative acceleration should mean slowing down, and a positive acceleration should mean speeding up. It's not quite that simple, unfortunately, because here we saw a negative acceleration that caused him to speed up. But it caused him to speed up in the negative direction. So we could think about it as the velocity is changing. In what direction? In the negative direction. That's interesting. We're going to come up with a rule in class, but I'm going to let you think about it a little bit. So the rule is not that a negative acceleration means slowing down. And it's not that a positive acceleration means speeding up. That's not the rule. What is the rule? We're going to revisit this question in class.